Hey, everybody, and welcome to another episode of the Vidor Locksmith Show. Today, we've got an amazing episode for you guys. Today, we're thinking once again a little outside of the normal box of just oil and gas. And today, we're talking about geothermal. So, the individual we're bringing on to the show today has actually been a former oil and gas participant and has now moved on to the geothermal environment. So without further ado, because we definitely want to be able to get into this one pretty quick, because obviously everybody else is going live at the same time today. Jody Robins, thank you so much for joining the show today, sir. I really do appreciate it.
Yeah, happy to be here, man.
All right, guys, for anybody that's out there watching, as per normal, if you guys can, please let us know where you're watching from. We would like to be able to know where. We give everybody shout outs here every once in a while during the show, is try to interact with you guys as much as we can. Just so you know, there is a 30-second delay on any of the communications we have here. So if you guys do ask a question, give us just a little bit and we'll try to be able to get to it and then get everything answered. I'm going to double check here to see if everything has gone right. It does say that we've gone live. That's good. So I'm going to go ahead and click on it. If you guys can't hear me, also let me know that just to make sure. Looks like Aaron Baxter's already watching. We're already up to about 21, 23 people watching right now. So that's good. Excellent. Because for some reason, NOV is going live and SPE is going live at the same time, and IADD is having a webinar. So I think we're all competing for eyeballs at the current moment. So anybody that is watching, we do appreciate it. So we've got Aaron Baxter, Gabriel Cruz, Drill Formats. Wow, we've got a lot of people coming in. Thank you guys for watching. All right. Jody, I know that you have become you mentioned this before, you've become a very popular person over the past couple of weeks. I'm not really sure why. It doesn't really seem like there's a whole lot going on in the energy world. But for our viewers and stuff that are out there, give us a little bit of your background.
Yeah, so I have 20 years in oil and gas, almost all of it in drilling or operations of some kind. I went to Penn State, started off at Texaco in New Orleans. Was there at Texaco / Chevron Texaco for 8 years, mostly drilling shelf and then in deep water. Moved to a small company called Spinnaker, stayed there for a couple years, then moved to, I wanted to move to Denver, so I came here with, who did I come here with? I came here for Denver. I was here for 2 years, and I moved out to California with Vinico for a couple years, and then moved back here with Fidelity. Fidelity went under, and so I've been with a private equity-backed, 2 different private equity-backed companies after that. About a year ago, I could kind of see where oil and gas was heading, especially in Denver, and so I started looking around for other opportunities. And came across this geothermal drilling job at NREL. And so I've been there for about a year now, almost exactly a year. It's definitely been interesting. I definitely miss oil and gas in a lot of ways, but right now I feel pretty good about where I'm at. It's kind of crazy in oil and gas world.
Okay, so then what is it that you miss about oil and gas?
Operations. NREL is primarily research, and so even though I'm working on some really cool stuff, I miss calling out to the rig, going out to the rig, making day-to-day decisions on drilling and things like that.
I think there's a lot of people in that same boat that are in oil and gas right now that are missing operations. So there's a lot of us that can feel with you on that one. So as obviously with your background being in oil and gas, how easy was of a transition was it to be able to go from oil and gas into the geothermal portion of the energy industry?
Yeah, it's there's a lot of similarities, really. Basically, you've got geologists who are out doing the exploration and trying to figure out where to drill, and then on the drilling side, it's you're just drilling a hole in the ground. It's just you're in much harder rock. Generally, you're drilling through granite or some other crystalline structure rock, and it's much hotter rock. That's what you're looking for, is high temperatures. So, you could be up to 350 degrees Celsius. So 600 degrees Fahrenheit.
Whoa.
By the time you TD the well. Yeah, so it's a whole nother level. And so a lot of as far as drilling, a lot of drilling tools don't work. as you get towards the bottom of geothermal wells, either because of the temperature or it's just, like trying to run PDC bits and that sort of rock can be tough.
So what would be a BHA that can make it to TD with those kind of temperatures?
Yeah, honestly, they generally do any steering pretty shallow, and by the time they get to TD, they're drilling with a pendulum bit, and they are rotary drilling, no motors, and using tricone bit.
Wow. So I'm guessing
yes, it's really old school.
I'm guessing the ROP and footage per day is pretty slow there towards the latter stages of the well.
Yeah, it's terrible. You're looking at 5 to 10 feet an hour, and you're tripping a bit almost every day or every other day, something like that.
So in some of the recent wells that you've done or something, I know obviously this can change depending on the area and just like any one of the other basins, but what kind of depths have you guys been going to as of recently, and where geographically have some of those operations taken place?
So depths are generally shallower because you're looking for places where you have high temperatures at shallow depths to explore. So even something like 8,000 feet is considered relatively deep. You're generally between 3,000 and 6,000 feet, something like that.
Wow.
Yeah, and almost all the operations in the U.S., all the operations are in the West. Most are in California or Nevada. You get some other stuff in Idaho, Utah, some other Western states. Nothing in Colorado, surprisingly. Nothing in Wyoming. But almost everything is in California or Nevada.
Excellent. So given the opportunity for some of these service companies that might be hearing this, what are some of the technologies or services that you guys might be looking for that could be a game changer for the geothermal operational space?
To me, I mean, just your geothermal companies aren't even able to do, standard good drilling practices because of lack of information. So high temperature MWD tools, high temperature motors, bits specifically designed for hard rock that can stand up to that type of heat also. You get in there with a standard standard for oil field BHA like that, I think you'd make a lot of progress just doing that.
Wow.
Yeah, I think high temperature electronics enabling high temperature MWD and LWD would really be a game changer for geothermal. But most oil and gas drilling tools are somewhat limited. What's the highest? 250 C around that temperature.
I would say standard is 175 C.
Right.
So anything beyond that is definitely going to be either a premium product or few and far between as far as utilization is concerned. So I'm not even sure what the top one out there is.
Right, and these guys, geothermal operators don't have the vast amounts of capital behind them like oil and gas do. So, and they're not drilling that many wells. So if they burn up an expensive MWD tool, it really hurts their bottom line. So they're a little more reticent to take risks, financial risks like that. So it's kind of like there's some of it is the tools aren't appropriate for the job, and some of it is they're just a little more conservative.
Yeah, I don't think anybody likes burning up MWD tools, to be honest.
Right. Yeah, you're looking at what, $1 million, $2 million hit.
I mean, regardless, whatever the price is, nobody wants to pay it. I know that. I've been a part of some of those tickets. Nobody wants to pay it. So we should probably take a step back and ask you, as far as like the geothermal process and like how to be able to essentially capture the energy. What is that process? What would be some of the basics to be able to explain it to somebody who's in oil and gas? Because now we've got conventional and unconventional wells. You're either fracking it or not, being able to produce the well. What's kind of the completions and production techniques for geothermal wells? Like, how do you guys actually take the operation you're doing, be able to turn that into money?
Sure. Yeah. So, so like I said before, it's kind of similar to oil and gas. You have geologists who are out looking for prospects. Even that is more difficult in geothermal because 3D generally does not work in these types of rocks. And so they, right now, kind of like the next big thing for geothermal exploration is play fairway analysis. And so, using something like that, or even something as simple as looking for ground expressions, looking for geysers or hot springs or something like that, and just drilling below that is how they find it. And so you need three things to make it work. You need high temperatures, obviously. You need some sort of fluid in place, usually a water or brine. And you need a fracture network because, again, you're dealing with granite, so there's no porosity or permeability in the rock. You need a significant fracture network. And as probably most people know, in oil and gas, it's hard to find fractures whenever you're looking for natural fractures. Drill an exploration well, and then at that point, do calculations and try to figure out. They generally do like a flow test for a good month or two to see what they can flow out of the well. You're looking at you need much higher rates in geothermal versus oil and gas to be able to produce power. So, where an oil and gas well might max out at 3,000 or 4,000 barrels a day, you're looking for 40,000 barrels a day in a geothermal well. So,
Whoa.
Generally, your production casing is 8.5 inch, or 9 5/8, or 13 3/8, and you're producing directly up the casing. You're not running tubing or anything like that. Generally, they have to run a downhole pump, and you're producing 40,000 barrels a day, cycling it through your plant, and then injecting it in another well or wells somewhere nearby, hopefully downstream of your producer, so you're replenishing your aquifer continuously.
Wow. That's I mean, I'm guessing
it's significantly different on that end.
I'm guessing the Topside facility has to be fairly large to be able to accommodate that amount of flow.
They're really not bad, and it's really quiet. It's kind of cool to go visit a geothermal facility. It's very different than like going to a gas plant or processing plant or something like that. It's quiet. It really doesn't smell too bad, and it doesn't. It really solar or wind. It's very small.
Wow. So I know we've got
and you generally you only have maybe up to 6 producers in for any one plant. So you're not dealing with 20 wells that are all making 40,000 barrels a day. It's not that big.
Okay. So I know we've got a couple of comments coming in here. People are talking about project economics, survey management, and then also the one I want to touch on first is Amy Fox, who's a geomechanics specialist, mentioned about some other technologies that are out there. So obviously, in the model that you just talked about, what you guys are doing is you're essentially just producing hot water. And I don't know if I'm using the wrong terms here, but you're producing hot water from downhole and then being able to use that to generate the energy, right, turn turbines, things of that nature. Obviously, there's some new technology out there with several different companies. I don't want to mention anybody because I'm not like promoting anyone in particular, but there's been talk of these closed loop systems. How does that change kind of the economics, and can you explain a little bit about how that technology works in as opposed to what you were just talking about there?
Yeah, sure. There's two kind of interesting technologies that are being pushed right now. One is EGS, which is Engineered Geothermal Systems, and geothermal systems, or just closed loop. So I'll talk about EGS first and then AGS. EGS, which is being heavily promoted by the DOE. So that, let me step back.
Yeah. Take your time.
A step here. The DOE provides quite a bit of funding. Yeah, DOE provides quite a bit of funding for NREL. And within the DOE is the geothermal group, GTO. So that's Geothermal Technology Office. And so they basically decide where to spend the money that is allocated for geothermal within the DOE. And definitely a big priority for them right now is EGS. There's a big test center called Forge, F-O-R-G-E, out in Utah, that they've already drilled a couple of wells there. And so that the idea behind EGS is to be a little more of horizontal wells, drill like one vertical well, frack in between them, and you're not looking, the fracture would be very different. You don't need proppant. You're just, you're basically just pumping fluid. And since it's these big crystalline structures, the idea is it should stay open. And then you just start pumping down two of the wells and producing up the third well. I think some of the difficulties there are it's opposite of oil and gas in that you're looking for a frac hit. You want to be able to connect the different well bores, but you also don't want to connect them too well. I think whenever they've done some EGS projects in Europe, they've had some fractures short circuit, and so the water doesn't get enough time in the horizon to heat up hot enough to create power. So it's like so that's really the difficulty with EGS. I mean, number one, can you drill horizontal wells in crystalline structure? I mean, I think you can, but how long is that going to take, and how expensive is that going to be? And then number two, how do you get your fractures right? You know, there's some thought that maybe you go down and you drill a horizontal well and frack it, and use microseismic to see how far the fractures go, and then that determines where you drill your vertical producer. But it's definitely early on in that technology. And so like one company that's really pushing this is called Fervo. You can go check out their website. And they are based out of Houston. It's run by an ex-oil and gas guy. And so they're doing a lot of interesting work. And then of course, like I said, the Forge, definitely go check out the Forge website. It's really cool. There's a lot planned there. There's a lot of money being devoted towards it. The other technology is AGS, so closed loop system. And so the idea behind that is you could use either a vertical well or a horizontal or horizontal wells, and you're using like a refrigerant, a better working fluid than water. And so hopefully the idea is it'll pick up the heat faster. You're basically mining the heat to the wellbore. So if you have any sort of highly toxic brines or something like that, you just don't have to deal with them. You don't have to worry about corrosion. Everything is self-contained within the well. And you've got two different kind of thoughts there. You can either do it in a horizontal, in a vertical well, where you kind of like pump down your tubing, and then you produce up the casing side, up your annulus.
Okay.
Or there's and so one company doing that is Greenfire. You can check out their website. And then there's also Ever, EAVOR, and those guys are up in Canada. And their idea is you drill 2 horizontal wells and connect the horizontals. They've already
That sounds like a bit of
tested this
a challenge.
once, and then yeah, I mean, that would be the most interesting one to work on as a drilling engineer, And they also did it the kind of exciting thing about that is they're doing it in a sedimentary basin. And so that's closer to what oil and gas does. You can go out and drill. We know how to do that. We know how to drill horizontal wells in sedimentary basins. And connecting them is really not that bad. And then, at first, whenever I heard about this, I thought, well, how are you going to make the casing connection? Well, they totally bypass that, and they pump some sort of like thick fluid around that seals off the wellbore. So it's basically like a thick, mud cake, and then they can use their working fluid inside of that, and it's separated from the wellbore. So the big advantage to both of these is whenever you're looking for somewhere to drill, you don't need fluid in place, and you don't need a fracture network. So all you need is heat. And heat can be found anywhere in the US or anywhere on the world if you drill down deep enough. So, they're kind of both thought of as geothermal anywhere. Right now our geothermal is really kind of limited to the western third of the US. If you get AGS or EGS work, in theory, the downside for those are they're kind of in early stages. It's early times, so there's definitely more work that needs to be done. And
Wow. So that if it's a closed loop system, then that really changes the lifespan of a well, because let's say that a conventional well comes on, has high initial production, then it's just going to slowly decay over the life of it, unless there's water flood or some enhanced oil recovery techniques put into it. But it's still going to be one of those things where it slowly decays over time. With a closed loop system, essentially, then you're looking at like a constant level being put out, as if all of the structural items that are in place stay there. Obviously if casing or wellheads or something like that break, there's problems there. But then it just becomes something at surface to be able to optimize the energy, or the energy conversion, I guess to say. Is that in saying that, is that a possibility there?
Yeah, that's right. I mean, even with conventional hydrothermal, geothermal that's around now, you know, these plants could be there for 50 years easily, and with no decrease in their capacity. There's a geothermal field in Italy that's been creating power for 100 years now. So that's pretty
Whoa.
crazy. And then the same thing with these closed loop systems. There's no reason to think. I think the big question with the closed loop systems is, do you mine all of the heat around the wellbore and then decrease your capacity to make power that way? And that's something that needs to be figured out still. But it's definitely different than like shale well, where you have you're vastly declined in 6 months or a year. You're definitely thinking you should be thinking about these projects in 30 to 50 year project timeline.
So given the current climate, and this will be the last question for me, so like I'll try to, because we've got tons of comments coming in. Given the current climate, does this help or hurt, or does it really matter as far as the longevity of geothermal? Can it be a overall global player in the energy market? Like, what needs to happen for it to really be able to to rise up and really start taking hold for the energy market per se?
Sure. Yeah. I mean, I think this is a really good opportunity for geothermal to grow. I think one issue with geothermal is just the talent pool hasn't been that big. Not too many people know about it. And so, if you get a bunch of people that have been working in oil and gas and just making incredible advancements over the last decade, all of a sudden, that your talent pool for geothermal operations is much bigger. You also have, I think there's going to have to be some sort of policy changes in the U.S. Geothermal's kind of been the forgotten about renewable resource. There's much more focus on solar and wind, and so it would be nice to see some changes there. And I will say that I was on a meeting with several geothermal operators recently, and they are also looking at this as an opportunity. Like, okay, rig prices are down. Most oil field services are down. You have all of these people looking for work. How can we capitalize on this? Can we pick up a bunch of rigs later this year or next year and drill a bunch of projects that have just been sitting there waiting? Part of that has to do with most of these projects are on the BLM. Surprisingly, it is much harder to get a geothermal project permitted than it is to get an oil and gas project permitted, even though you're just drilling for, like you said, hot water. I think the geothermal industry just doesn't have, they don't have the they don't have the money. They haven't been able to get the changes that oil and gas have. So even if you just change some of the rules so it's the same as oil and gas, which seems like it should be pretty obvious to do, that would help quite a bit. I think the other thing that everybody needs to understand is, as of now, geothermal is a pretty small market. There are definitely going to be some opportunities there, but over the last 5 years, while oil and gas has been drilling tens of thousands of wells, geothermal has in the U.S. now 12 to 14 wells a year, new wells. So it's pretty small.
Wow.
Now, like I said, operators are thinking about they'd like to pick up the pace next year or later this year. But you're still not talking about a huge market. I think there's potential there in the future for, if EGS or AGS are successful, then you are thinking about a huge market. But as of now, geothermal really needs people. It needs people who are going to come in and innovate. Like some of the companies I mentioned earlier, I would count them all as innovators, and it needs capital. So that's the one place where this downturn could hurt geothermal in a way, because if you're hoping that maybe oil and gas companies get into the geothermal market, which seems like a natural fit, all of a sudden they have less money to spend on R&D, and so maybe that slows down. But I think on the whole, it's definitely a big opportunity for geothermal to try to grow.
So I do want to address a couple of the questions that we've had here in the comment section so far. So we had Neil Armstrong with Merlin ERD, a couple of guys across the pond, great guys there. They asked, are there any closed loop systems in operation today?
Yes, Greenfire ran a test system in the Coso field, which is out in California. And I know it's, they count it as success, but I don't know the details there. And then also Ever was able to connect to, I think they drilled 2 laterals. And so the horizontal laterals, it's a multilateral with 2 coming out of each well bore, and they were able to connect those up in Canada. I'm not sure exactly where, and they did successfully pump their sealing fluid and have their working fluid circulating without pumps, because it's like just natural convection.
Wow.
But again, I don't know what that means. I don't know, they haven't talked about what that flow rate looks like and what kind of power that could generate, but it was their initial test, and it definitely looks like a success.
So then we had another one. This question was from Laura Stadler. Laura's somebody is always watching the show, so Laura, thank you. What allows it to stay active in Italy versus other locations? So I think she's talking about the well that you had mentioned that had been active for over 100 years. What's allowing that one to be able to continually keep going for so long?
Well, it's important to whenever after you use the water, basically take the heat out of the water to create your electricity. It's important to re-inject it into the same aquifer, or I don't know, into the same zone, I guess. And so you continually replenish it. One thing I haven't talked about is initially, there's different type of plants. There's some that use steam. And so you actually produce steam out of the ground, and that turns the turbines. And then now, much more popular are binary systems. And so what you do is you produce the water. You don't need as high temperature, so you don't have steam. And so you have your water, and then you have a second refrigerant like working fluid, and you have a heat interchange there. And so, the heat basically transfers from your water to the refrigerant, and the refrigerant gets flashed through the turbine. And so with that system, you basically keep your 100% of your water, and then you're able to re-inject it. And so, in theory, if you're re-injecting it in the right place, you're continuously replenishing your aquifer.
Sorry, I hit the wrong button there. I took myself off of the thing instead of putting it back up. Also, I mean, it's cool to be able to hear about that as far as, like almost like the intercooler effect of being able to use these systems. Another question that we've got from Hamzi, who's a technical business development at, I can't see the rest of it, but he says, is high shock and vibration a typical concern while drilling these types of wells? If so, what is typically done to mitigate? So kind of back onto the drilling side of stuff.
Yeah, I mean, absolutely. That's why they're not using PDCs, because you get one, you slam into one thing, and all of a sudden you've lost the cutter and you destroy your bit, right? So that's why they're out there just drilling with a pendulum BHA and tricone bits, just because they're hardier and can stand a little bit more getting bashed around. But I think if you have high temperature MWD tools down there, then the other thing is you're rotary drilling, and so you're just, if you're 8,000 feet in the ground, you're not getting very good information at the bit. If you all of a sudden are back using MWD like normal, you can see what's happening at bit. Maybe then you can start running some PDCs and see some faster ROP. Be able to control your vibrations better, that sort of thing. I mean, it's just standard drilling practices that they're just not able to do at this point.
Hold on. There we go. I've got to I keep wanting to press the wrong button. I figured out if I take myself off the screen, then your resolution kind of goes up. So I'm going to try to keep. Nobody's here to hear me talk anyways. They're always here for the guest. So this is all about you. So then we got another question here. That was, is hotter the better? Producing more joules for sure. So, oh, then the screen moved. So I'm guessing that I'll just go to the question. So the hotter the well, the better? Or is there like a tipping point to where it's like, okay, this is too hot? And then what's also like, what's a minimum temperature that you think that this could be done with?
Okay. Yeah, I mean, hotter is definitely better. It's just more efficient. You can take more of you have more heat to create electricity with. And so that's another place of growth for geothermal that people are trying to figure out right now. It's called supercritical. So up in Iceland, they've drilled a couple of supercritical wells, and some other place, I think Italy and somewhere else. And so basically you drill down until water is in a supercritical state, and it's just extremely, extremely hot. And so from one well, maybe you can make 10 times the electricity versus just a standard geothermal well. The hard part about supercritical is you're talking about like 500 or 600 degrees Celsius. And so you've got real problems with, what kind of casing is going to stand up to that? Carbon steel loses all of its strength at that point. And so they've had a real problem with these wells with casing collapse. And then you're also dealing with super, super, super corrosive brines. And so how do you deal with that in your wellbore, and how do you deal with that at the surface? So again, that's another place where the closed loop systems might really be the answer. Is you drill down to these super high temperatures, and then you run a closed loop system, so you don't have to deal with those. You don't have to deal with those brines. You don't have to worry about how they're going to react at surface, and if there's corrosive elements, or if it's H2S or norm. Instead you've just got whatever working fluid you're using, and you just deal with that at surface.
Wow, it's funny to think about, like, how at some point in time casing's failing because you get such hot fluid running through it. It's just something not normal in oil and gas to even start to think about. At least not for me.
That's right.
There's probably other people that are way smarter than I am. They're like, "Oh, you're so silly. You haven't worked in this area." But it's all new to me.
And you're very limited as to what casing grades you can run, because in general there is some CO2 or H2S present, and so you can't run any P110 or anything like that. So basically, you're just getting thicker and thicker casing to deal with it. And there's some places, the Salton Sea in California, where it's all highly corrosive. They are running. They're having to run like zinc carbon steel alloys, or even titanium casing, which, as you might imagine, is kind of expensive.
Wow, none of that sounds cheap.
No, yeah, it's super, super expensive.
Those are the kind of things that show up on an AFE, and you're like, "Are you sure we can't go any cheaper?" So, wow. We did have a question from somebody here that was asking about what's the predominant style geothermal drilling for heating homes in like Iceland. So I know that in Europe there's certain spots where they do some like shallow geothermal stuff to be able to heat homes. That's from what I know, that's a different technology than what is being done as far as obviously these larger wells. But are the concepts similar?
Okay, so I think there's two different concepts there that you're talking about.
Yeah.
The first is there's geothermal heat pumps, and so we have those in the U.S. We actually, I think, have more in the U.S. than anywhere else, any other country, and that's basically like an HVAC system. You have to drill a hole to like 300 or 400 feet, something like that. Or, in the case of like big buildings, they'll go out and excavate fairly deep, and you use the lower temperatures, or I guess the standard temperatures of shallow earth, and you use that for heat. Heat in the winter, and you can use it to help cool in the summer. Now, what they are doing in Iceland and in Europe is direct use, and it's not something that we do very much in the U.S. for some reason. We're really have the geothermal industry has been focused on electricity generation. In Europe, where they don't really have as high temperatures in the subsurface as we do, they focus more on direct use, where they drill similar style geothermal wells But instead of creating electricity at surface, they send it through like a system of pipes and heat people's houses. So like Munich is heated by a geothermal system. And it's really cool. And I am not clear why it isn't very popular in the US. There are something like 21 systems, like Boise, Idaho, is heated with a system like this. But it's definitely I mean, it seems like a growth opportunity for sure. I have a feeling, I think part of the problem is that Europe is much more dense. And so, the cities that have been built are denser, and they were built before forced air systems. And so I think, using geothermal makes a lot more sense whenever you're using like a hot water heat system. But yeah, I'm not clear why those aren't more popular here in the U.S. And geothermal is growing at a faster rate outside of the U.S. Europe and Iceland are really pushing it. Turkey is really growing their geothermal industry. New Zealand, Japan. It makes a lot of sense for islands. Instead of having
Okay.
to import oil, heating oil or diesel or something like that. If you can be self-sufficient with geothermal, then that helps quite a bit. And also islands happen to, generally sit on near tectonic activity, which is also generally where you can find geothermal potential.
Yeah, so that would definitely help out as far as drilling more shallow wells. We did have a question, and I should say this for anybody that's watching, please tag a friend or share this so that other people who may be looking for a job or looking for other places to be able to convert their knowledge set in oil and gas could potentially take this over to geothermal. Granted, there's probably not as many jobs there, but if there are any, it is definitely worth looking for. So one of the questions is what's the affected acreage for drilling some of these wells? Do you have to do essentially the same stuff with oil and gas where you're going out and getting, thousands of acres and trying to bundle them together to be able to put together like a field plan, or can this be done on a smaller scale?
Yeah, it's pretty similar where there's lease sales, and most of the geothermal operations in the U.S. are on BLM land. There's some that aren't, but I don't know what percentage, but it's a high percentage is on BLM. And so, it's the same thing where you can nominate acreage, you have BLM lease sales. As you might imagine, the acreage values are significantly smaller. They go for quite a bit cheaper. And then you go out and you explore, and the big difference then becomes your development process is usually like 8 to 10 years to get a plant built, just because you have to go through multiple EAs, dealing with NEPA and things like that. Like I mentioned before, it's much more difficult than getting oil and gas project permitted.
All right, so
you're also you're also looking at a much smaller well field for, like I think I said this before also. So you're looking at maybe 2 to 4 producing wells, and then maybe another 8 to 10 injectors, something like that. And then you might have some other wells that are they're monitoring wells just to make sure that your injectors are injecting where they should be, and to monitor, you need to make sure that you're not your temperature of your reservoir isn't decreasing, and also that you aren't injecting your water into the wrong fracture system, and losing it basically to your power generation.
So I asked, is there like a geothermal drilling group, or like an SPE or an IEDC for the geothermal process?
So the best geothermal industry group is the GRC.
I'm gonna write this down.
Yeah. In the U.S., there's some other ones. There's some other ones like in Europe called EGEC, and IRENA. But the best one in the U.S. is GRC. Very similar to the SPE, except much smaller.
It's probably a good thing.
Right. They have an annual meeting, / convention, very similar to SPE. This year it's in Reno, hopefully in October, depending on COVID and if there's a second spike, I suppose. So I went to there last year. It was in Palm Springs, and I went to that convention last year. It was really cool. There's a few oil and gas companies there. Scientific was there. Schlumberger has a company called Geothermex that does some geothermal work. There were a few others around, but on the whole, it's kind of I guess the big companies in geothermal. Ormat is by far the biggest. There is an Israeli company, and here in the U.S., they are the largest operator, and they are continuing to grow and buy up other competitors. Calpine out in California is pretty large. They operate the geysers, which is one of the older and the biggest U.S. Geothermal field. GRG is a consulting company that basically drills and produces geothermal wells around the world. So those are some of the best folks. CYRQ is another company that's one of the larger operators.
Excellent. And so what's the, obviously for people who have been in geothermal for, their career and stuff, how do they feel about oil and gas people coming over? Are you welcomed with open arms?
I think if you're somebody, I think if you're somebody looking to make a change, and you want to go and talk to Ormat in Reno or something, I think there's been kind of a in the past, oil and gas people have talked kind of down to geothermal folks, and acted like they know everything, and like, oh, why are you guys drilling so slow? Why aren't you doing this? Why aren't you doing that? And and at first glance, that is definitely what you think coming from oil and gas. It's like, oh my gosh, I can't believe these guys aren't running this tool. They aren't using these bits. What are they doing? And then whenever you get actually into the challenges, I mean, these are legitimate challenges. These folks aren't dumb. There's you want to be careful that you kind of don't talk down to them, and you don't act like the challenges are irrelevant. because it's really hard to drill these wells. And really what needs to happen is, like I said, you can't use what exists for oil and gas. It's just, it's not appropriate. It's not fit for purpose. But, it seems like if oil and gas service companies really get interested in this, they could get there. Like why isn't, Baker Hughes going to be able to build a better PDC bit? Why isn't Halliburton going to be able to build, high temperature LWD bit, MWD, if they really want to get into this? The question is, it's like a chicken or the egg kind of thing. The market is small, but the market is small is because there hasn't been a lot of capital put into it. So it's like, how do you grow the market? Well, we need to get oil and gas service companies and operators interested. Well, they're not interested because the market's too small. So it seems like somebody there needs to, and maybe this starts with employees at these larger companies saying, look, this is really interesting. We should pursue it and kind of push it up the line. But it seems like somebody is going to kind of break that seal and really push into geothermal, and then it'll just make a lot of sense. It'll just start growing. But somebody's got to do that.
Well, there's definitely the case to be made that you could start saying, hey, this worked on a geothermal well, so it will definitely work on a oil and gas well. So maybe it starts with some bragging rights for some of the service companies. I can almost guarantee that you'll probably be getting a lot of messages from service companies or consultants or vendors after this, people wanting to know more or wanting to be able to attend some of the events or potentially get their tools downhole, because I know everybody's desperate for work right now. So we did get another question in there, which was, should a petroleum engineering student with a background in drilling start looking at a potential geothermal career?
I mean, I don't think it can hurt. It's if, like I said, there's not going to be, as of now, a ton of those jobs available, but why wouldn't you? It seems like even though there's less money in geothermal as far as investment, if you can get into it, it's pretty steady. There might be fewer jobs, but you don't have the big ups and downs like you do in oil and gas. I mean, that's one of the things that was attractive to me whenever I came over to this job at NREL. It's like, I wanted to stay in Denver, and oil and gas was so spotty here. It's like, okay, well, let me try geothermal, and it seems like if I can get into that industry, then it'll be a little bit more even keel.
Yeah, I think
I don't see any reason why you wouldn't.
Yeah, I think the roller coaster we've been on this week has been exhilarating, to say the least. So for anybody who's not up for those kind of dopamine rushes, maybe something a little bit more subdued might be the thing to do. So we did get a question here from Jasper Dawson. In the US, what is the average depth for a closed loop well?
Well, as of now, there's only one, and I'm not sure. I think it's probably around 4,000 to 6,000 feet would be my guess.
All right.
So but the thing is if you're successful with that and you start drilling wells, say in the Northeast, where you have to drill deeper to get to that the kind of heat that you need for power generation, then you might be looking at 20 to 30,000 foot wells, and totally different. Yeah, a little bit more interesting, definitely more difficult. But yeah, if you're successful with geothermal anywhere, you're gonna have to be prepared to drill down until you get to the heat.
All right. I have to say, Kurt Armbruster, who's been in the comment section. He's asked a couple of questions. I've missed them from where they're at, but he's been answering other people's questions. And he just said, I'd love to get into drilling some closed loop wells. Such a fascinating challenge. So Kurt, thank you for watching. We really do appreciate it. So finally, I want to be able to ask this, because I know we talked about this before. What are some of the cool technologies you guys are working on right now?
Yeah, I mean, the coolest project I'm working on, you can go see, there is some public data around it. It's electropulse drilling. It's called the Repid tool, and it's being funded by ARPA-E. ARPA-E is Advanced Research Project Agency in Energy. And so basically it's a government group agency that funds high-risk projects. If it's low risk, then they're not interested in it. They're looking for game-changing things. And so we're working with this company called TetraCorp, and it's a electropulse drilling tool. And I can't say a lot about it because it is proprietary. It is there are some larger companies backing it that are hoping to commercialize it at some point. But the idea is, instead of using a drag bit, PDC bit, whatever, you're going down there and using pulses of electricity to destroy the rock, and then you're able to circulate it back up. And in limited testing, we've seen much higher ROPs, and also, instead of having to run multiple bits, we're hoping that you would be able to run this bit in multiple wells. And there's a bunch of different technologies out there being worked on for that focusing on geothermal wells that would also be applicable to oil and gas, really. There's like plasma drilling, there's laser drilling, there's projectile drilling, there's millimeter wave drilling. The really good thing about this one is that you really change nothing at surface. Like, for the driller at surface, nothing's going to look different. You're still circulating mud down the hole. You're still circulating your cuttings back up your annulus. You're just drilling with electricity instead of a rock bit. And so yeah, I mean that's one really cool thing that I'm working on, and I don't know. I have high hopes for it. I think it'll be it could be a real game changer. If it increases ROP by 10 times what you're currently seeing, that is going to significantly change the economics of these wells.
So for people that might want to research what you're talking about, what was it called again?
Yeah, so go to the ARPA-E website and search for REPED, REPED 250.
The 250.
Right. And so,
okay.
Yeah, so that's repetitive pulsed electric drill, and 250 is 250C. So making it applicable or usable in high temperature wells.
And so would this be something that could be converted over to oil and gas?
Absolutely. I mean, this is the Repid 250. It's the lower temperature version is being looked at for oil and gas. They're trying to get that to work, and we're trying to get the higher temperature version to work.
Wow. That. I remember you told me about that before, and then I was like, I needed to write that down. because I wanted to go look it up right away, and I was trying to find it, and I was like, I'm getting some of the acronym wrong somewhere in here. So,
yeah, it's really cool. Check it out, and you can also look at the at NREL. Our geothermal group had a 2019 like group highlight paper. If you go look for that. And it's like an achievements booklet, and in there's also a write-up that it's fairly similar, but it might have some additional information versus what's on the RPE site.
Yeah, and somebody just
and you can see what else we're doing at NREL.
Oh, that's definitely going to be interesting to be able to see kind of what else is going on there within the organization. Somebody in the comments, Isaac, just said GA drilling from Slovakia is another, and they're doing a plasma bit technology.
Yeah, I'm not familiar with it other than I know that it's out there, and it's like, it's great, right? Like, I mean, you want all of these companies competing with each other to figure out, you know, a replacement for current bits. You know, so that's good. You want competition, I think.
I'm really interested in seeing what the BHA formations are for these, because obviously I'm an MWD guy by background, and that's what I'm really passionate about. So any kind of electronics that go into the BHA assembly, whether it's for the bit, for, you know, measurements, for logging, any of that stuff, I kind of geek out on it. And, you know, I'm really interested in seeing how some of these different new bit technologies work, and what systems, you know, obviously would be paired with them. So that's definitely something that I will be spending some time working on here pretty soon.
Yeah, I mean, for the Repid, you know, the big thing we're looking on is making the electronics high temperature, and there's no reason why that couldn't be applied to the electronics that are in MWD tools. And I don't think there's any reason why you couldn't put an MWD tool in this BHA. Yeah, I can't get into specifics, but I think that would work.
I think it's probably the only thing is going to be temperature limitations. But then again, if we can get away from some of the things that are required for oil and gas, and we can go more towards, you know, knowing exactly what the requirements are for a geothermal well, that might open up the envelope just a little bit to be able to put different types of equipment or pieces of hardware into some of these systems, so that they can be more specifically driven for the geothermal wells. Because if you don't need as high of accuracy with wellbore location, because it seems like, you know, if you're drilling blind for the last whatever the distance is, then, you know, some of those things are what really limits some of these different MWD technologies. So maybe you can go with lower grade stuff and be able to not have 0.05 accuracy, but you can just have 0.5 or 1 degree of accuracy.
Yeah, and I mean, and another thing is that you know, generally in geothermal wells, in traditional geothermal wells, you're looking for losses. These are mostly under pressured or naturally pressured formations, and when you have losses, that means you've run into a fracture network. And so, you know, as you know, if you have massive losses, you can't use mud pulse technology to see your information. So, you know, that leads you to think, well, maybe we need to improve and make more common wired pipe and things like that. And that might make running MWD tools and geothermal wells a little more realistic. But then again, you need then your wired pipe has to be, you know, also temperature appropriate.
Yes. All right. Trying to see, make sure we didn't have any last questions. Some stuff came through real quick. Be interesting to see how much more complex BHAs need to be on the surface. So we just got a handful of comments in there. So I want to say this, everybody that's been watching, thank you guys so much. Please still tag anybody that you think would get some benefit from watching this, even as we're kind of wrapping up here. They can go back and be able to see this. So I ask you guys, please, for the 51, I think we're hitting our peak like right here at the end. So the 51 people that are still out there watching, I want to say thank you. And if you guys want to, please feel free to reach out to Jody Robins, connect with him here on LinkedIn. He's been putting out some good content, things that you can read up about the similarities there. So if you're looking to be able to transition your career, maybe from oil and gas over to a new area where you can have some applicable skill sets to be able to help out, and maybe find something that's a little bit more stable, a little bit more flat as far as the ups and downs are considered with oil and gas. So here's one good question. So this is my buddy Aaron Baxter. Aaron says, do you ever see flask MWD systems, essentially a heat exchanger? So I'm guessing a MWD system within a cooled unit to be able to keep it.
Yeah, you know what? Actually, Baker Hughes developed one, and you can find this. It's public information if you go Google it. They did create a high temperature system, and it basically used some sort of like vacuum insulation and active cooling. But honestly, I don't know what became of that. That's one of the things I've been kind of trying to run down over the last few months is why haven't people run that? Is it still available? Yeah, I don't know is the answer. But I know that they created one. There's a few papers out there that I found.
Oh, excellent. Well, then maybe I've got some Baker Hughes contacts, so maybe I can help run that down for you, even though everybody's playing musical chairs right now. So get in touch with the right person is somewhat difficult at times.
Right. Yeah, if they're still around.
Yeah. Well, guys, everybody out there, thank you guys so much for watching. So we've got Carlos H., Toby Puente, Armin Federico. We even had Jenny Wilson back in there. You guys, thank you guys so much for watching today. Jody, thank you so much for being on the show. Any last words for everybody out there? Maybe a bit of advice to everybody in the oil and gas business, or even in the geothermal, because I know we had some geothermal people watching today too.
Yeah, man, thanks for having me on. This is fun. Definitely a first for me. It's been, once I started posting a bunch of geothermal information, that with all the people that I know in oil and gas, it's been interesting to see all the interest. Yeah, I mean, it's tough times for everybody right now, right? Like it's negative oil prices a couple days ago, and just things we never thought we would see. Yeah, I mean, I think there's a lot of potential in geothermal. It's if we're able to create some interest today and get service companies or people at majors really interested in this and start looking at some R&D. I don't think it would take a lot to really start changing the economics of these wells. You get some smart people working on this. I think things could change pretty quickly, but let's hope that happens. Let's hope that today's talk helps somebody go get a job, and it'll all be worth it.
Yeah, I would say this: if a podcast can lead to somebody getting a job, all of the podcasts that I have ever done have like, you know, there's a win that, and that's I can take away from that. So thank you guys so much. Lee House, thank you for watching. Is another guy that's been kind of there in the comment section. Once again, guys, if please tag anybody. If you're still watching, please tag somebody in the comments so they can go back and be able to watch this. If you guys want to be able to find some more information about any of the geothermal wells, what I'm going to do is I've got a couple of links from Jody. I'm going to put them into the comment section of this, or just make a subsequent post on LinkedIn later on, so that you guys can follow up. I am talking to another person in the geothermal space that wants to come on and talk about a new kind of competition per se. I can't say too much, but there's some things that are happening here in the near future that I want to be able to let you guys know about. So please stay tuned, stay interested in this topic. There's more to come with this. Once again, Jody, thank you so much for taking the time to be able to talk with us. I know I learned a lot from this, and it's been a wonderful experience. Thank you so much. And for everybody else out there watching, as always, know your industry.